Hello and welcome to a new Voltlog. Today we're going to be taking a look at this QuickCharge 2.0 wall adapter. This was recommended by a viewer. He sent me an email saying that this was on a special offer on gearbest.com. So I got this one for $3.69. And I saw that just today when shooting this video it was selling for $3.89. So it's a good price if it can match its rated specs. It should be a 15 watt output power and quick charge 2.0 capable, so it should be able to output 5 volts, 9 volts or 12 volts depending on the negotiation between the charger and the device under charge. So 15 watts at 5 volts should mean up to 3 amps output. So we'll be taking a look at some measurements today. I want to measure if the this adapter can indeed output those 15 watts. So I will be checking if I can get 3 amps at 5 volts. I want to check if the voltage drops at that output current, and I also want to measure the voltage ripple at that output current. Then I want to take a look at some of its protection features. It does have overcurrent protection, so I want to check at what current that protection kicks in. I want to check the short circuit protection. Then I want to leave it running for about half an hour and check the temperature at the exterior of the case. I don't have a thermal camera, but I will use one of those IR thermometers. And then towards the end of the video we'll do a teardown just to check some of the safety aspects of this charger. I don't have a dummy load capable of testing quick charge devices, so I'll only be testing this at 5 volts. I don't have anything that will talk to this charger and make it switch to 9 volts or 12 volts. But I assume that that's handled by a small chip inside, and there's nothing really that can go wrong with that. I expect that to be working. So first let's get started on testing the output current. I'm going to be using this dummy load, and if you haven't seen this one before, there will be a link on the screen right now to a video where I reviewed this dummy load, and also there will be a link in the description so you can get one like this. I have assembled this cable with a USB plug that will go into the charger. These thicker leads will go into the dummy load, and I can measure voltage right here at the output of the charger with a multimeter. Or I could also run a second set of wires and use the 4-wire measurement mode on the dummy load, but for simplicity I'm going to use a multimeter connected right at the output of the charger. So this is my setup. I'm using this multimeter to measure voltage right at the output of the adapter, and the dummy load disconnected. So I'm going to plug this in. Okay, so with no load we're seeing 5.2 volts. Yeah, let's start with a 1 amp load. So it can do 1 amp at 5 volts with no problem. The output voltage is still at 5.2 volts, so that's okay. It seems like they provisioned for slightly higher output voltage just to be within the range when the voltage starts dropping. So let's increase the current to 2 amps. Okay, now we are at 2 amps. And we can see the voltage has dropped slightly at 5.17 volts, but it looks like it's going back up, so it might have a slightly slower voltage regulation loop. I'm not sure. Let's go up to 3 amps. So So the dummy load is pulling 3 amps right now from this charger, and as we can see, the voltage it's still quite okay, and it seems to have that behavior that I noticed earlier. It's regaining voltage after it has lost it on the initial change of output current. So right now I'm pulling 15 watts out of this AC adapter, and it seems to be doing just fine. Now we might as well test the overcurrent protection. I'm going to increase the current over 3 amps and see around which value the overcurrent protection trips in. So let's see, 3.1, 3.2, 3.3, 3.4, 3.5 amps. Wow, so we can pull more than 15 watts and the overcurrent protection hasn't kicked in yet. Let's see, 3.6. Okay, so that's our sweet spot. So if we go over 3.5 amps, the overcurrent protection tripped, and it actually reset itself very fast. So now the output voltage is available again. Okay, so that's good to know. It's capable of outputting 15 watts with no problems, and the overcurrent protection is set at around 3.55 amps or something in that region. In this case, that overcurrent protection is also our short circuit protection, I'm pretty sure, because in case of a short circuit, the current will increase over that 3.5 amps figure and will trip the protection. So they're kind of the same thing, the overcurrent protection and the short circuit protection. For measuring the output ripple, I tried to get the oscilloscope probe as close as possible to the actual output of this AC adapter. So I'm using that small ground lead to minimize the ground loop. So let's go back and take a look at the oscilloscope. So here is a measurement of the voltage ripple output when the adapter is in standby, so there is no current pulled from the adapter right now, and we're seeing a figure of around 70 to 80 millivolts peak to peak noise. We do see some nasty spikes from time to time. I'm not sure if those are visible on video. If not, I'm going to attach a screenshot later in post editing. So let's start our dummy load at 1 amp and see what kind of ripple we're getting. Wow, so the noise increased quite a lot. Yeah, so it looks something like this. Roughly 140 millivolts peak to peak output noise at 1 amp. Let's go up to 2 amps. We're kind of seeing the same maximum peaks at around 170, maybe 180 millivolts peak to peak, but it's kind of more condensed, so the frequency of the noise might have increased. Let's go up to the full 3 amps. Yeah, so at 3 amps we're getting peaks of 190 up to 200 millivolts of ripple noise, and I'm not sure what the spec is for these USB chargers, but I would think 200 millivolts might be acceptable at this kind of voltages. So we have about 5.2 volts output with 200 millivolts peak to peak noise. The voltage is not going to swing below 5 volts. So maybe you can let me know in the comment section below, what do you think about this noise figure at the full rated 3 amps for this AC adapter. Is this acceptable to have 200 millivolts of noise on the output or not? And if we look closely, the figure increased slightly in the past minute up to 230 millivolts. So is this something that increases over time with temperature? Maybe there is a temperature rise inside, and the capacitors maybe don't have the same capacity on the output, so they're not capable of filtering the same amount of noise. I'm not sure, but I can definitely see that number increasing over time. So we are now at 250 millivolts peak to peak. So I'm going to leave this running for another 5 minutes or so, and check back after that. So the ripple has increased quite a lot. I need to change my vertical scale. Yeah, so we are now at 400 millivolts, around 10 minutes of working at the full rated output power. And by the way, this is the perfect moment for shooting a video because there is a snow blizzard outside, and basically all the roads in this district where I live have been closed by the authorities. And there's heavy snowing outside. I have heard from a couple of friends that there are power outages in their areas, but I still have power in my area, so I'm able to shoot these videos for you guys. I'm still curious what will happen if I leave this running for half an hour. How much is this noise going to increase, or is the AC adapter going to die because of overheating? Actually, let me check the temperature on the outside case. Yeah, I'm seeing about 50 degrees. This is not, yeah, 52 degrees I'm getting right now. So this is not a very accurate measurement, but as I don't have a thermal camera, this is the best I'm going to get. Yeah, so if we're seeing 52 degrees on the outside of this plastic enclosure, I'm quite sure we have about 70 degrees, maybe more, on the actual PCB or on some of the active components soldered on that PCB. But we'll see that later when we do a teardown. So the dummy load just shut off. That means the voltage on the output dropped below 4.5 volts because that was the setting. So watch this, guys. I think we do have a thermal shutdown happening. So the ripple has reached about 480 millivolts, but we'll see how the output turns off, and the dummy load senses that and it automatically shuts down. So yeah, you saw that the output went down, and I think that is a thermal protection. Let's check the temperature on the outside of this enclosure. Yeah, 54, I'm getting 54. Yeah, so it's 54 degrees, the highest I could get on the outside of that enclosure. But the ripple, as you saw on the oscilloscope, went up to 480 millivolts peak to peak. And it seems we cannot run this AC adapter at the full rated power for 3 amps at 5 volts for longer than 10-15 minutes. It will overheat and the thermal protection will kick in. And by the way, the ambient temperature right now it's about 26 degrees Celsius. So I have other AC adapters. I have the ones from Blitzwolf, the ones that you can get on Banggood, and those can output their full rated power no matter how long you run them. But this one doesn't look like it can do it. So next we're going to do a teardown of this device and see what we get inside. Unfortunately, I don't have any insulation testers, so I can't really test the insulation of the small transformer they have inside or of the actual PCB design. But we'll look for some visual cues like the creepage distance between the hot and the cold side of the circuit. It's not going to be easy to open this. It looks like it's been welded, and I think my best try is to try and cut around this seam, and maybe the whole PCB will slide out this way. So I'm going to try. I'm not going to use a Dremel because that will make quite a mess. First I'm going to try with a big knife and just cut around this seam and see if I'm successful that way. The knife didn't quite do the trick. This was quite thick and hard plastic, so I had to resort to the Dremel. But now I think we can pop this lid off. I hope I didn't cut any components inside. Yeah, I think this cap almost escaped the Dremel disc. So I'm going to pause momentarily before I try to extract this PCB. So I finally managed to pull the PCB out of the enclosure. It had 2 wires soldered in, so I think the PCB is supposed to go in from this other end, and I had to pull those, to rip those wires because they were soldered right here on the input. So let's take a closer look at this PCB. Looks like we have an input filtering cap, 6.8 microfarads, 400 volts, and the brand is not sure, I don't recognize this brand. But we do have a bridge rectifier, what looks like a control IC. This must be the main switcher. I couldn't find any info about this chip. In fact, let me check the numbers. So this guy has 30630 written on it. I couldn't find any info or datasheet by googling these numbers. There is just an IMU chip from InvenSense that keeps popping up, but I'm pretty sure this is the main control IC for this power supply, and we can see it's using an external MOSFET. Then we have some we have the transformer. By the way, we have some nice clearance between the primary and the secondary. In fact, let's measure that. It's like more than 5 millimeters. Actually something like 7 millimeters. So yeah, quite good clearance with a cutout right under this capacitor. So yeah, I'm quite another cutout under the optocoupler, so quite a nice isolation. So from this point of view, I would say this power supply is safe, but it also depends on how this transformer is built, because this transformer also provides the isolation between the primary and the secondary, and if there isn't enough isolation between the different layers of copper wire, then we might have a problem. That could be easily tested with an insulation tester, but as I don't have one, we'll have to skip that test. What I don't see though is a big inductor on the output. I mean, this thing is capable of 3 amps output. We saw it could even go up to 3.5 amps, but we don't have any inductor except for this one, which at first looks like a ferrite bead, but I'm not sure. Could this be the inductor for this switch mode power supply? I don't know. Let me know what you think in the comment section below. And as for the output capacitance, looks like we have a couple of capacitors right here, 270 microfarads, 16 volts, and another one right here, different value, 330 microfarads, 16 volts. But I'm pretty sure these are crappy capacitors, and if we were to remove these and measure them, I think we will see they don't have the rated value. And as we noticed during our test, the ripple voltage increased as the temperature increased, so it might be that these capacitors lose their value as the temperature increases on the board. And we have another small 6-pin chip right here. This must be the chip handling the QuickCharge output voltage, but I'm not sure how that could be switching the voltage from 5 to 9 or 12 volts. It could be that we have 3 different outputs on this transformer, and maybe the chip is just selecting between which output is connected to the actual USB output socket. I'm not sure how this whole QuickCharge thing works, but I don't see any other way how we could get three different voltages just by changing something on the primary. I mean, the efficiency could be very low if something only changes on the primary. But if we have different secondary windings, then we can get a winding for each voltage. So that's about all we get for this AC adapter. A very simple design, but as we saw, not capable of sustaining its full rated 15 watts output power for more than 5 minutes. So in terms of safety, yes, I think this is usable, but in terms of specifications, it doesn't meet its advertised specs. So I don't know, it's up to you to decide if you could use one of these. I mean, the price is quite low, but if you ask me, I would pay something extra and get a higher quality charger, like the Blitzwolf ones, which have been tested by a lot of guys on the internet, and all of their test results show they can sustain their output power and they meet the specifications. So that was all for today. Please let me know in the comment sections below if you enjoy this kind of teardowns, and don't forget to like and subscribe to my channel. See you next time.